All right, identify the transformation that carries the figure onto itself. In other words, after we complete these transformations, we want it to look the exact same way that it looks now. All right, so if we reflect across the line x equals -5, this is the line x equals -5, so it would end up over here. And then if we rotated it 180 degrees about this point, we would end up somewhere over here. It wouldn't map onto itself. All right, let's check the next one. If we reflect across the line y equals -5, this is the line y equals -5, so it would end up here. And then if we rotated it 180 degrees around that central point, again, it's not going to end up right where it's at. I'm just kind of giving a rough estimate here, and I'm not actually doing it, but I hope that you can see that you can really solve it the same way. So if you look at the next one, reflect across the line x equals -3. So that line is right here. If you reflect across that line, it's going to give you the exact same square. All right, and then it says rotate 630 degrees around -3, -8. Okay, so we need to figure out what it means when it says rotate 630 degrees. What we could do is we could take 630 and subtract off 360, and that gives us 270 degrees. So in other words, you're rotating at a full rotation and then 270 more degrees. The center of rotation is in the center of this figure, and 270, let me start over. This figure does have rotational symmetry every 90 degrees. So 90, 180, 270, 360, all of those are gonna be places that you can rotate it to map it onto itself. So this one does actually work.